Hello, my name is Olugbenga George. In this project, I built a model to predict the net hourly electrical power output of a combined cycle power plant using historical sensor data. The dataset has 9,568 hourly observation with 4 environmental inputs. Had the ambient temperature, exhaust vacuum, ambient pressure, and relative humidity. The target variable is power output in megawatts. So this is a supervised regression problem because the output is continuous. So to evaluate accuracy, I chose root mean squared error, which is RMSE, since it shows the average prediction error in megawatts. A lower RMSE basically means better performance. So these are my right here. These are my inputs, and my output is right here. So I included all 4 features because each one directly influences plant performance. For example, high temperature and high vacuum readings usually lower output, while higher pressure and humidity will generally increase it. Um, so I used the Excel regression output. This is my table with coefficients and R2. I also used 2 approaches in Excel. First, the data analysis 2-pack regression tool. That gave me the regression coefficients, which is R2 values and the significance test. The model achieved the R2 of about 0.93, meaning it explains 93% of the variance in power output. Second, I rebuilt the regression manually using coefficients and Excel formula. Right here, this confirmed the prediction basically matched the two packer results right here. This basically is my formula, Excel formula. Then I compared the 2-pack regression and the formula-based regression. So both are the same linear model. So their training RMSE was about 4.5 um, megawatts right here. I also compared these to a baseline model that always predicts the average output. That baseline um, had RMSE over 17 megawatts. So the regression was a much better choice. And I'm giving the strong performance statistical significance of all the features and also the interpretability. I kind of like selected the multiple linear regression model as my final model. Finally, I tested the model on a held out test set that was never used for training. And on this test set, the regression achieved RMSE of around 4.5 megawatts and R2 of about 0.93. That means basically the model is highly accurate and generalizes well to unseen data. Here's a scatter plots of actual versus predicted output. I had a red line here basically showing the 45-degree um, line. But basically, you can see close, uh, see the points lie close to the 45-degree, showing strong agreement. So right here, showing a strong agreement between the prediction and actual plant output. So to conclude, this project demonstrates how Excel can be used, or rather how I use Excel to build a reliable regression model from data preparation through validation, model comparison, and finally evaluation. So in summary, I defined the problem as regression with RMSE as the metric. I used all 4 features to build a multiple regression model in Excel, validated it and compared it, and finally demonstrated strong um, accuracy with R2 of 0.93 and RMSE of 4.5 megawatts on a test set. Thank you.